Hello students, see this question from IITJEE 1993. We have a particle P sliding down a frictionless hemispherical bowl. It passes the point A at t equal to 0. At this time, instant of time, the horizontal component of its velocity is v. A bead Q of the same mass as P is ejected from A at t equal to 0 along the horizontal string AB with speed v. Friction between the bead and the string may be neglected. Let Tp and Tq be the respective times taken by P and Q to reach the point B. Then so we have got a hemispherical bowl over here. We are releasing a particle A along the bowl. It is traveling the path along the bowl. But the condition is that when you're giving A some velocity, the x component of velocity is v. If this is your initial velocity of A, its x component is equal to v. Another particle Q is allowed to slide along the horizontal string AB. It is also given the same velocity v. So basically both the particles have same initial velocity along x-axis. Okay, now understand something. When the particle P is over here, it will be experiencing a normal force in this direction. This is your normal force, right? This normal force has horizontal component. This normal force will have a horizontal component. So this normal force will accelerate the particle along x-axis. Similarly, when the particle reaches over here, normal force will now be acting like this, and its the horizontal component of normal force is now acting in opposite direction, so it will decelerate the particle along x-axis. Now let's just draw the graphs. So if I draw the graph for velocity along x-axis as a function of time, and if this is your initial speed v along x-axis, okay, then if I draw the graph for particle q, the graph for particle q will be a horizontal straight line. Okay, this is a graph for particle q. It is a horizontal straight line. But when you talk about the graph of particle p, then its x component of velocity is first increasing because of this normal force and then decreasing because of the normal force. So x component is starting from the same point, but first it will go up and then it will come down like this. Okay, so now when we talk about this time over here t, then in this much of time interval, let me just name them first. This is your particle p. This is the velocity graph of particle p. This is the velocity graph of particle q. So in time interval t, graph of particle p is covering more area. That means displacement of p will be more than displacement of q. Area of this graph is more than the area of the graph for q, and area under vt graph is displacement. So displacement of p is more than displacement of q in the same time. Or we could say that for the same displacement, time taken by p will be less than that of q. Okay, in the same time p is covering more displacement, and for the same displacement p will take less time. That's why you get option A.